Picture this. You've got exactly 20 minutes before your computer science paper 2 mock exam begins. You flip the paper over and boom, this code snippet is staring right back at you. Dim number as integer. Number equals console.readline. It looks completely innocent, right? But can you spot the critical marks losing error in that loop before the clock runs out?
Welcome to this explainer. Today, we're throwing basic definitions right out the window. Instead, we're going to bridge that massive gap between just memorizing programming syntax and consistently nailing those top-band Cambridge exam answers. If you're tackling the IGCSE 0478 syllabus, consider this your ultimate survival guide for Visual Basic console apps. Let's get right into it.
Section 1. The Mock Exam Trap.
So here's the thing about ordinary revision. It totally traps you into just memorizing code syntax. It feels like you're making progress, sure, but it is incredibly brittle the second an exam question throws you a curveball. Mark scheme thinking, on the other hand, is a completely different ballgame. Cambridge examiners don't just hand out points because you vaguely remembered a line of Visual Basic. They reward logic, algorithmic design, and structured thinking. That's a totally separate skill, and your framework absolutely has to come first.
Section 2. Console Apps Explained. Let's clear up exactly what we're working with here. A console application is simply a program that uses a text-based command line interface on Windows. The absolute key takeaway? It is totally uncluttered by a graphical user interface, or GUI. It's strictly text-based. And honestly, that makes it the perfect sandbox for you to test your algorithmic logic without getting bogged down by dragging and dropping buttons or design elements.
This distinction right here is literally where so many students waste precious revision time. Listen, console apps are strictly required for the 0478 syllabus. Windows Forms apps, the ones with the fancy graphical interfaces, they're entirely optional and absolutely not covered in your syllabus. So please don't waste hours building pretty windows. Console apps are the exact tool you need to master to secure your marks.
Section 3. Logic before language. Check this out because this is the golden rule in action. Compare a simple pseudocode command like input number 1 to its actual Visual Basic translation, number equals console.readline. You can instantly see the structural difference, right down to how comments are written, double slashes in pseudocode versus a single quote in BB. For paper 2, you always want to master your algorithmic logic in pseudocode first before you even think about translating it into Visual Basic. Logic first, language second, every single time. If you adopt this simple 3-step pipeline, I promise you'll never freeze up staring at a blank Visual Studio screen again. Step 1, truly understand the core mechanism of the problem. Step 2, write that logic out in pseudocode. Step 3, finally implement the Visual Basic code. Build this habit, and programming questions stop being terrifying and start becoming totally predictable. Section 4, IGCSE Command Wants. You can instantly upgrade your exam game just by decoding what the examiner actually wants from you. If they say state, just give a concise fact. Describe, they want characteristics. Explain means you need to provide the why or the how. Compare demands you look at both sides. And calculate means, you guessed it, show your exact working. You absolutely must match your answer format to these specific command words and apply them directly to whatever scenario the question throws at you. And here's a crucial rule straight from the examiners themselves. One mark usually needs one distinct technical point. Avoid repeating one point in different wording. Basically, waffling is not going to save you here. Writing 3 long, vague sentences that ultimately say the exact same thing will still only net you a single mark. In computer science, precision is literally your ultimate weapon. Section 5. Upgrading flawed answers.
So, how do we secure maximum marks on those tricky descriptive questions? You use this 4-part framework to build an ironclad answer. First, state the concept. Second, provide evidence from the given scenario. Third, layer in your technical reasoning. And fourth, lock it down by using precise examiner wording. Let's pause the explainer for a second. Take a look at this student's answer. The program uses verification to ensure the inputted integer is between 1 and 10. Can you spot exactly why this answer just bled crucial marks in a high-stakes scenario? Think carefully about your data checks.
Okay, so the massive flaw here is that the student completely confused verification with validation. Just checking if a number falls between 2 values is not verification. A top-band answer uses razor-sharp terminology. It should say, uses a validation range check to ensure the inputted integer is within the boundary of 1 and 10. A range check is validation. Nailing that exact terminology is exactly what pushes your grade into that top band. Section 6, Interactive Challenge. Let's put this to the test. If our validation rule accepts integers from 1 to 10, what type of test data is the number 10, and what type is the number 11? Put yourself in the shoes of an examiner designing a trace table right now. How would you officially classify those specific inputs? Here's the breakdown. The number 10 is boundary data because it sits right on the absolute edge of your acceptable limits. The number 11, however, is abnormal data since it falls completely outside that acceptable range and should trigger your program to immediately reject it. Honestly, mastering the difference between normal, abnormal, boundary, and extreme data is an absolute must for dominating Paper 2 testing and evaluation questions. Section 7. Next steps for survival. To make sure you never miss out on a critical exam strategy or framework like the ones we've covered today, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE. We've got everything you need to completely excel in your Cambridge exams. Because, look, here's the final hurdle. You know exactly how to flawlessly tackle state and explain questions now. But what's going to happen when you flip to the very back of the paper and face a devastating 6-mark evaluate question? The framework we just went over works like a charm until you hit those massive, open-ended scenarios. How on earth do you guarantee full marks when an examiner asks you to evaluate an entire, complex algorithm?
Well, that unresolved problem is exactly what we're going to conquer in our next explainer, where we break down the specific structure needed to crush those high-mark questions. Be sure to check that out to complete your exam survival plan. But until then, I want to leave you with this. If a beautifully written algorithm works perfectly, but uses absolutely zero validation, is it actually a functional solution at all?